Indiana University East School of Natural Science and Mathematics. Stoichiometry problems involving compounds. So what we're going to do now is talk about how to solve stoichiometry problems involving compounds. And there are two main sets of conversion factors we can use. Firstly, we can use the chemical formula to create a conversion factor between the number of moles of atoms of a particular element and number of moles of that compound. For example, for carbon dioxide, we know that there are 2 atoms of oxygen for every molecule of carbon dioxide, so we have the conversion factor 2 moles of oxygen for every mole of carbon dioxide. Of course, we can also flip it over as we need to. We also can use the molar mass, which is based on the molecular mass, to convert between the mass of a sample and the number of moles of a particular compound. So for example, we know that the molecular mass of carbon dioxide is 44.01 AMU. The molar mass has the same numerical value as the molecular mass. And therefore we can use this as a conversion factor. So you have 44.01 grams per mole. Of course I can flip it over as well. So in terms of problem solving, there are 2 main techniques. One, use the number of moles as central point. There's really no right or wrong way of doing these problems, but what I found useful is to go for a number of moles. You might add a couple of steps, but you will get it right every time. Go to number of moles of whatever you have, and then convert to what you need. And in particular, the dimension analysis technique is a technique of choice here. Because at the end of the day, all you have to do is to write out your units. So the trick here is to write out quantities carefully, including the identity of the substance. And be careful to cancel out units as appropriate. So let's take a couple of examples. How many molecules of ethane are there in 0.334 grams of ethane? The molecular mass of ethane is 30.07 AMU. So the molar mass is 30.07 grams per mole. I'm looking for the number of molecules of C2H6, and that would be 0.334 grams of C2H6. I then need to go to moles, right? And so I need to get rid of grams, so that's 30.07 grams of C2H6 for 1 mole of C2H6. I cancel that out. And then, because I'm looking for the number of molecules, I know that each mole of C2H6 includes 6.022 times 10 to the 23 molecules of C2H6. And so I check, and that's what I'm left with. And therefore, the number of molecules, when I go through and do the calculations, is 6.69 times 10 to the 21 molecules. The next problem is a bit more involved. I have a sample of 341 grams of CuFeS2. I'm looking for a number of the mass of copper in this. So here I'm going to start with the number of grams. I want number of grams of copper, and I start with the number of grams of CuFeS2. And I will need to go and look for the number of moles of CuFeS2. The molar mass of this is 183.52 grams per mole. So there's 183.52 grams of CuFeS2 for every mole of CuFeS2. And now that I have the number of moles of CuFeS2, I know that in every mole of CuFeS2 there's one atom. Every one mole, I mean. So in each mole CuFeS2 there is one mole of Cu, and I know that the molar mass of copper is 63.55 grams for every mole of copper. So when all is said and done, I have 118 grams.